Section 4.5 is kind of a quick section because it's mostly review. We're going to be solving and graphing linear systems of inequalities. Now we'll start with a couple friendly problems to get going. Let me remind you of a few things about graphing linear inequalities. First thing you're going to do is you're going to graph the corresponding equation. So who remembers what the graph of x equals -1 is going to look like? What's that going to look like? That? Something else? Yeah, more like that, more like touchdown. All right, cool. So, yeah, x equals -1 is going to be a vertical line. Now, which side of that vertical line do you think I'm going to shade? Am I going to shade the left side or the right side? Which way am I going to find? Now, remember, I'm trying to graph x is greater than or equal to -1. So we already determined that the graph of this is this vertical line. Am I going to shade to the right or to the left? Where am I going to find numbers that are bigger than -1? To the right. So let's just do that here. There. I need to do likewise with y is greater than 2. Now for y is greater than 2, let's start out by graphing the equation first. Miriam, what's the graph of y equals 2 going to look like here? Some help there? Yes? Well, if you look at the points that satisfy the line x equal 1, let's make a little t-table of points. X equals -1. Now, if y is 0, what is x? It's -1. If y is 2, x is still -1. If y is 4, x is -1. In fact, it doesn't really matter what y is, correct? So if you plot these, -1 and 0, -1 and 2, -1 and 4, what you'll find is that they all lie on the same vertical line. Here, here, here. So that's why you get that vertical line. Now, I'll go back and do the shading part in a minute. But Judy, what's a line y equals 2 look like? What's its graph going to look like? Horizontal line. Good. And what should I take care of as I draw this horizontal line? Yeah, thank you. Make it dashed. Now, where am I going to shade that horizontal line? Above or below? Above. All right, so that would be this one. Let's get rid of that. Do you notice anything interesting about this graph? I mean, from a mathematical perspective. What happened with one of these regions? They overlapped. And where they overlap is your solution. Now, I'll give you a couple possibilities. One possibility when you do your work is this. You can shade both sides and then look where they overlap and then circle it or write solution where they overlap. Something to let me know that you understand that the solution is what they have in common, is where those two things overlap. Now, another possibility here is if you just kind of look at these things and go, you know what? I know I'm going to shade to the right here, and I know I'm going to shade above here. Oh, I can visualize where they're going to overlap. The other possibility is just shade the region where they overlap, like that. I probably would suggest that the first one's maybe a little bit better, but either one works. Your solution is where they overlap, and I'll ask you on the test to carefully indicate your solution. And here's two alternatives for you. Shade everything, circle where they overlap, or just shade where they overlap. Whatever works. Your turn for one. Problem number 26. Kind of a little bit of a repeat of this previous one. X is less than or equal to 0, and y is less than 0. So carefully try and graph both of those. So I'll draw one of these in green. The other one, I'll use a very manly salmon pink. Yeah, she's not quite salmon pink, but whatever. See if you can't sketch both of those. Try and figure out what the solution is. Okay, Ying, maybe you can help us out with the first graph. What's that going to look like? X is less than or equal to 0. All right, draw a vertical line here. What side of that vertical line should I be shading? Yeah, to the left side, the less than side. Cool. Let's move over to the next one. So what I have here graphed is x equals 0. Shane, how about this one? What should I do for the graph of y is less than 0? All right, that's going to be a horizontal line. The line y equals 0 is your x-axis. And as I draw that horizontal line, what should I take care to do? Excellent. Make it dashed. Thank you, sir. Where does that horizontal line get shaded, above or below? Carrie? You want numbers that are less than 0, so that's going to be below the x-axis. Now, if you're not sure, what could you do? Test a point, sure. Now, I can't use 0, 0. That's my favorite test point. I can't use 0, 0. What would be a good test point to choose? 1, 1? Sure. 1, 1 is right here. So I'll test 1, 1. That's x and y. There's no place to plug in for x, but I can plug in for y. Is 1 less than 0? No. So that means I want to shade the other side of the line, because that's where the true points are. This one's false, so we want to shade the other side of the line. So down here. Now if you left it like this, I'd be a little bit unhappy, because I will take care, and I want you to take care. On the test, I'll take care to say carefully or clearly indicate your solution. So I'd want you to either circle this or write solution on the region where they overlap. I think circling is probably best. Just tell me you understand, okay, that's my solution. That's where they overlap. Yay. How we look on these two. These are warm-up problems, but they're good problems in as much as they remind us some things about solving or graphing linear inequalities, etc. The additional step is what? The additional step is just realizing that the solution is where the two shaded regions overlap. That's the additional step here for us. Other than that, it's a good reminder on graphing and graphing linear inequalities. Let's move down to problem number 32. Try and crank out a few more here. Want to at least do 32 and 34 would be good problems here. 32, We've got y is greater than 2x minus 4. And y is greater than negative x minus 1. Now, in graphing these, I first have to start by graphing each equation. Y equals 2x minus 4. Y equals negative x minus 1. These aren't quite so easy as the previous couple. The previous few we had horizontal and vertical lines. You can pretty much look at those. Here you're going to have to be a little bit more careful. X and Y, X and Y. Madeline, if you could help me figure out some values to use for this first one, that'd be great. Alright, if I plug in a 0 for x, 2 times 0 minus 4 gives me negative 4. Great. I need one more point though, at least one more point. Well, you could plug in 0 for y, and that'd be fine. You could solve for x. But because y is already by itself, probably just as easy to plug in another value for x. I'm not going to make you graph the x and y intercepts. That's great if you remember doing that. So let's just plug in a 1 or a 2. 2 times 2 minus 4 gives me, good, 0. So 0, negative 4 is down here. 2 and 0 is here. Let's draw this with a blue line right there. What can you tell me about that blue line? Dwayne? How should I graph that blue line? Say again? Alright, I've got the points, but I'm kind of thinking of this part up here. Yeah, I was looking for his dashed. Alright, so this is a dashed line. Alright, so dash line here. And let's now graph this one down here. X equals negative x, or y equals negative x minus 1. As before, we'll start out with a 0 here. Plug in a 0 for x. We get negative 1 for y. What else can I plug in? Let me go with a 2 for x, just because if I'm trying to plot x equal 1, sometimes they get a little bit too close together. I want to give myself a little more room. If I put in a 2 for x, now what do I get for y? Derek, maybe help me out with that? If I put in a 2 for x, what do I get for y? Negative 2 minus 1, negative 3, thank you. So 0, negative 1, and 2, negative 3. What line should I use to draw these two? Solid line, good. Because the less than, you know what? Was this a less than, or did I copy it down right? Yeah, it should have been greater than or equal to here, right? Yeah, so I should be using a solid line. So, solid line through those. Now I got to figure out where am I going to shade. So, okay, let's do that. 0, 0 is our favorite test point, and we can actually use 0, 0 to test both lines. So this is your line y equals 2x minus 4, and this is the line y equals negative x minus 1. Zoom out a little bit. Let's see about testing both of these. We'll test 0, 0 in this line. So let me see. Yeah, so let's test 0, 0. I'm going to give myself some room on another sheet of paper here. Test 0, 0. So let's think here. Plug that in here. Y greater than 2 times x minus 4. I think it was so 0 greater than 2 times 0 minus 4 is 0 greater than negative 4. Yes. So where do I want to shade? Kind of up to the right, above. Actually, not really to the right. More or less above, because we're testing in this inequality. So I'd say, well, this side, right? All right. However you want to phrase it, it's that side. Let's test the other one. So test 0, 0 again. This time we're going to test it in y is greater than or equal to negative x minus 1. Is 0 greater than or equal to negative of 0 minus 1? True or false? True. 0 is greater than or equal to negative 1 is true. What I want you to do is figure out where you're going to shade and then try and indicate the solution. See if you can't figure out where you're going to shade and then the solution. We just tested this line here. Test it out. True. Patricia, where am I going to shade, above or below? Okay. Brian? Above. So this point tested out true, and it's above the line. So I want to shade everything on that same side. So your solution then is where they overlap. Right up here. Yay. Okay, so I use the same point, 0, 0, to test in both inequalities. So when I tested in the first inequality, in this one, I put in 0, 0. 0 is greater than negative 4. That's true. Now you compare the test point to your line. Since it tested out true, that means every point on the same side of the line is also going to test out true. So that's the points that satisfy the inequality. That's why I shaded above. Now, had this tested out false, I'd be shading the other side. And I did that for this line too. I tested out another point. It also happened to test out true. So I shaded the same side of the line that that point was on. So I shaded kind of above to the right on this line. Now those two shaded regions overlapped. And where they overlap, that's your solution. Let's do one last one. It's problem number 34. I think you'll be in good shape for these. I'm going to help things out a little bit in terms of the graph. We've got two inequalities. One is y is greater than negative x plus 2, and the other one is y is less than negative x plus 4. I'll graph this one in orange and this one in blue. So as far as this one's concerned, you're going to graph y equals negative x plus 2. The easy thing to do is to plot some points. Setting x equals 0 gives me y equals 2. Setting x equals 2 gives me y equals 0. And I get a couple quick points here. I'm going to connect these with a dashed line. You can do the same thing for this equation up here, y equals negative x plus 4, and you're going to get points at 0, 4, and 4 and 0. And again, you're going to connect it with a dashed line. The challenging part is to figure out where we're going to shade. I'm going to use the same test point for both of these. So let's start by testing it in this first inequality. So we'll test 0, 0. We're going to test that in the orange inequality. Is 0 greater than negative of 0 plus 2? Is 0 greater than 2? That's false. Who was it? Yeah. Well, this is below here. You want to shade above. I'll tell you what. This is what we're going to do. I'm just going to write a little arrow here for the moment to remind myself that I'm shading above this line. Let's also test the blue line. So let's test there. Test 0, 0. In this inequality, is 0 less than negative of 0 plus 4? Is 0 less than 4? That's true. Now let's keep ourselves oriented. This point was on this side of the line, and it tested out true. So am I going to shade below or above? Below. So I'm going to shade down here like this. Try and use your imagination. Use what they sometimes call your mind's eye to see where these shaded regions are going to overlap. And try and shade just that part. I'll tell you what. Let me go up here. Let's see here. This is backwards. That should be less than, and that's a greater than. So when we tested the line y equals negative x plus 4. There should be a y in there. Y equals that. There you go. So the point 0, 0 is right here. When we tested that, it tested out true. Let's put in the point 0, 0. 0, comma 0. That tested out true. So I want to shade below there, right? That's what we're going to do when we graph this. Oops. Is shade below. Shading everything below that line. Because it's true. Now, with the other one, when we graphed y equals negative x plus 2, when we tested there, it tested false. So we're shading above. So you're shading above on that one and below on the other one. So could you see where they're overlapping? Hopefully, what you have shaded in your paper was that region in between here, this part right here. There's one last thing I'm going to do with this example, and you don't have to copy anything down. But let me just ask you this. What if I change these things up? If I change this to a less than, and I change this to a greater than, oops, greater than here. Now let's take a look at the graphs. And the graphs, Desmos is doing all the shading for you. What's the solution now? Ah, very good. There's no solution because they don't overlap, right? So the correct answer for a problem like this would be that there's no solution. And please write that on a test if there's something like that comes up. There's no solution. All right, for homework. Section 4.5 for homework. Try 15 through 25 and 31 through 41. If you bring in your homework completed on Wednesday, I might be giving out some extra credit homework or extra credit points on that. So good luck. See ya.